Hi everyone, I feel kind of bad. Today the plan was for a live lesson in class, but I'm homesick, so I've prepared a video for you to watch in class and take notes on. Um, I also feel bad. The last time I did a video and I said I was going to put a picture of myself up, many of you probably didn't realize this, but that was not a picture of me. That was actually a picture of um, Matt Damon, and that's not me. So today I'm going to put up an actual picture of myself for today's lesson. So let me get rid of this. Okay. So today we're taking a look at something called completing the square. And you guys can just fill in the blanks here as I talk my way through this. So the process of completing the square converts quadratic functions from standard form, and standard form looks like y equals ax squared plus bx plus c. So it changes it from standard form to the form that we're more familiar with, which is vertex form. And vertex form is y equals a bracket x minus h squared plus k. And the main reason we want to change it from standard form to vertex form is because it's much easier to graph, and we've seen that because we've been working just in vertex form recently, and we've figured out that it's pretty easy to graph it when it's in vertex form. So we're going to go through some examples here so you see how the steps work for completing the square. So for example here, I'll use my colorful yellow ball here. So there's an example of an equation in standard form. This is what it looks like when it's changed into vertex form. And there are a few steps involved. So for this example, we're going to change the quadratic function into vertex form, and then we're going to state some characteristics about that parabola once we've changed it. So the first step that we take when we have it in standard form is we're going to move the c value to the other side, and the c value is that number that's on the end. So if I move that to the other side, it's going to look like that. So the plus 7 changes to a minus 7 when it goes to the other side. The next step then is to divide everything by the a value. So the a value is the value that's in front of the x squared, so we're going to divide everything by that, and here's what that's going to look like. So you can see we divided 3 on the left side, so we put a line underneath the y minus 7 and divide it by 3. We divide this term by 3, and we divide this term by 3. And there's some simplifying that we can do here. The main reason that we divide by the 3 is so that we can get rid of the 3 that's in front of the x squared. So these two 3's here divide each other out, and 3 divides into 6 two times. So that's what it looks like when we simplify things. Now here's where the fun begins. So now what we want to do is we're going to take, there's the b value, so the number in front of the x is the b value. We're going to take that b value, we're going to take half of that and then square it. So if I take half of that 2, I get 1, and then when I square 1, I get 1. And my next step then is to add that value to both sides. So if I do that, here's what the equation is going to look like. So you can see that I've added 1 to the left side here, and I've added 1 to what we had on the right side up above here. So at this point you're probably thinking, man, we're just making a bigger mess of this. But here's where our factoring comes into play, because what we've done by doing that last step is we've created a perfect square trinomial here. So if we follow those steps, this will always be a perfect square trinomial. If you don't recognize it, then you can just factor it the normal way. But that's what we want to do now, is factor that. And if I factor that perfect square trinomial on the right side, I end up with x plus 1 squared. Alright, so if I was going to write two brackets for this, I need two numbers that multiply to give 1 and add to give 2. So those two numbers are plus 1 and plus 1. And so you see, that's where the x plus 1 squared comes from, is because we get the same thing in both brackets up above there. Okay, so it's starting to look closer to vertex form. Now really, what we need to do is move everything away from the y. So over on the side with the y here, we've got a plus 1, we've got a 3 that's dividing, and we've got a minus 7. So all three of those numbers have to be moved to the other side one at a time. The first one we're going to move is this number here. So the number that's the furthest away from the y, we're going to move to the other side. So when we move that plus 1 to the other side, it's going to change to minus 1. So it's going to look like that. Next, we're going to move the number that's dividing. So this 3 that's dividing on the bottom is going to move to the other side, and it has to multiply by each term on the other side. So when that 3 moves over, it's going to be multiplied by the bracket. So I've got 3 times x plus 1 squared. And it also has to be multiplied by the negative 1, so I have 3x times negative 1. And when I multiply those, the nice thing here is that we're just going to leave the 3 out in front here, because remember, we're trying to change it into vertex form, and that's what vertex form looks like, is with the bracket there. So we're going to leave the 3 out in front, and then 3 times negative 1 is just going to be negative 3. And then our last step is to just move that last number, which is the minus 7, to the other side. And it becomes plus 7. And when we simplify that at the very end, we end up with y equals 3 bracket x plus 1 squared, and then plus 4 on the end. Now up above, we were asked to find the vertex, the equation of the axis of symmetry, and the direction of opening, and the step pattern. So we've got the vertex is minus 1, 4. Remember, the axis of symmetry is going to be x equals whatever the x value is in the vertex. So the axis of symmetry, that line that cuts the parabola in half, is going to be at x equals negative 1. And then the other two pieces of information we needed, we know that it opens up, because that's a positive at the beginning right after the equal sign. And remember, our step pattern is normally 1, 3, 5, but we're multiplying it by 3 out in front here, so it's going to change to 3, 9, 15. Okay, so let's take a look at the next question. So same idea here, just more practice for us. So first step, if you remember what we did in the first example, I'm going to move that plus 11 to the other side and make it minus 11. Next thing I need to do is divide the number in front of the x squared. I divide it once on the other side underneath both things, and then I divide it by each of these separately. And when we simplify that part, you can see that the 2 and the 2 cross each other out, so we have x squared. And here 2 divides into negative 12, negative 6 times, and the other side we just leave for now. And then we go off to the side here, and we do a little bit of work. So here we have to take that number that's in front of the x, we take half of that, So half of negative 6 is negative 3. And then we do negative 3 squared and we get 9. And once we get that 9, we have to add that 9 to both sides of the equation. So we put a plus 9 there and a plus 9 there. Once we get to this point, the reason we've added that 9 is so that we can square this trinomial here. So this trinomial here is a perfect square trinomial, right? The square root of 9 is 3. The square root of x squared is x. And the sine always comes from the second term up above. So that's what it looks like when I factor it. And now I have to move these three numbers away from the y. And remember the order that I'd move them in. I'm going to move that 9 first. So when I move the 9 to the other side, it changes to minus 9. Next, I'm going to move the 2 that's dividing. And when I move it to the other side, I'm going to multiply it by the bracket and by the negative 9 on the end. So remember, the good news is that we don't have to expand the bracket. We just stick the 2 in front. That just sticks in front there. And then 2 times negative 9 gives us negative 18 on the end. And our last step, we bring that negative 11 to the other side, becomes positive 11. And then we simplify things and we have y equals 2x minus 3 squared minus 7. So to answer our questions, there's our vertex. Remember, we change the sign of the number in the bracket and we keep the sign of the number on the end. So 3, negative 7 is the vertex. Axis of symmetry is x equals 3. Again, coming from the vertex. It opens up because it's positive out in front. And this time our a value is 2. So the step pattern gets multiplied by 2, so it changes to 2, 6, and 10. One thing I want you to be aware of is the direction of opening and the step pattern we can actually get from the original equation. So when it's in standard form, we can figure those things out. So we know that this parabola is going to open up and the step pattern is going to be multiplied by 2. We know that even when it's in standard form at the beginning. The big thing, and the important thing really though, is figuring out what the vertex is, and we can't do that unless it's in vertex form. Okay, so now we're going to do a couple of questions where we complete the square and we use our information to graph the functions. So this time notice we have a negative 3 out in front. Okay, first step still the same though. I'm going to move that minus 5 to the other side. Remember, it changes to plus 5. Now I have to multiply everything by negative 3. So I divide this side by negative 3 and then each of these terms by negative 3. I simplify those. So when I simplify those, negative 3 divided by negative 3 is just 1x squared. Negative 3 divided into 6 is negative 2, and the other side just stays the same. Now we've got to do some work with this guy. So remember, we go off to the side here. We take half of negative 2. That's negative 1. And then we have to square negative 1. So negative 1 squared is negative 1 times negative 1, which gives us positive 1. So that positive 1 we add to one side and we add to the other side. And the reason we do that is to create this perfect square trinomial. So the square root of x squared is x, and the square root of 1 is 1, and the negative comes from the negative. We don't do anything with the left side here. It stays exactly the same while we factor the right side. Alright, so now we have to move things away from the y. So the plus 1 moves over here to become minus 1. Next up is the negative 3. When the negative 3 moves the other side, I multiply it by the bracket, and I multiply it by the negative 1 here. So when I do that, I'm going to get negative 3 out in front of the bracket, and then negative 3 times negative 1 gives me positive 3 here. And last thing I have to do is move that plus 5 over. It changes to negative 5, and when we simplify that, we get negative 2 there. So my list of items here, the vertex is 1, negative 2. The axis symmetry is x equals 1, right from the first number in the vertex. And this one opens down because of the negative. Whoops. Don't go all glitchy on me now. Okay, so it opens down because of the negative 3 that's out in front here. And if I multiply the step pattern by that negative 3, I get negative 3, negative 9, negative 15. So this one, we wanted to graph it. So I've got enough information here to graph it. First thing I'm going to do is plot the vertex. So the vertex is at 1, negative 2. So there's the vertex. And then I can just count the step pattern. So over 1, down 3. And then over 1, down 9, I'm way off the graph. So I don't have to plot that point. I just go over 1 and down 3 on the other side. And then I sketch my parabola through the points that I have there. Okay. And the last one here, this one, whoops, this one has a fraction out in front. So that's going to make things a little different than the ones we've done. So first step still the same. We're going to take that minus 3 to the other side, and it's going to change to plus 3 on the other side. Now I need to divide everything by 1/2. So on the left side of the equation, I've got y plus 3 over 1/2. On this side of the equation, I've got 1/2 x squared, like I did up above, divided by 1/2. And then I've got 2x divided by 1/2. Now when we're cleaning that up, sometimes here you may get a fraction in front of the x value when you simplify these, and that's fine if you get a fraction there. It makes it a little bit messier for your next step, but that can happen, so just be aware of that. We don't do anything with this 1/2 here, but 1/2 and 1/2, they cross each other out, and we just get the x squared that we wanted. And if I divide 1/2 into 2, I get 4. So now I have to work with that 4 to figure out what number I need to create a perfect square trinomial. So I do 1/2 of 4, which is 2, and then I square the 2. So I end up putting 4 in on the end of the left side and on the end of the right side. So there's my plus 4 on the left side, my plus 4 on the right side. And once I've got those there, now I can I can factor this trinomial here. Perfect square trinomial. So the square root of x squared is x. The square root of 4 is 2. And there's a plus sign in the middle here, so that's going to be a plus right there. And once we've done the factoring, now we want to move all these numbers away from the y. So first thing I move is the 4. 4 goes to the other side and changes to minus 4. Next thing I need to do is move the 1/2 to the other side. And remember, I have to multiply it by each thing on the other side. So 1/2 times the bracket and 1/2 times negative 4. So the 1/2 gets stuck in front of the bracket right there. And if I do 1/2 times negative 4, I get negative 2. And then I bring this 3 over. The 3 is going to change to a negative 3. And when I put it together with the negative 2, I get negative 5 on the end. Okay, so for this one here, the vertex, remember we changed the sign of the number in the bracket, so it's -2, -5. The axis of symmetry comes from the vertex at x equals -2. This one opens up, that's a positive. Okay, it is a compression, but it's still opening up because that's a positive 1/2. And for the step pattern, with 1/2 we can just change it to a decimal and multiply. So our step pattern is 0.5, 1.5, 2.5. So if I look at the parabola here, my vertex is right there at -2, -5. And then my step pattern is over 1, up a half. Then it's over 1, up 1.5. So there's up a half, there's up 1.5. And now over 1 and up 2.5. So 1, 2.5. So that's what the parabola of y equals 1/2 x plus 2 squared minus 5 looks like. Okay, so you're going to have a few practice questions to work on today, and tomorrow, there'll be no video tonight. Tomorrow is going to be a work period because we want to practice this a little bit more. Okay, and pretty soon we'll be getting into some word problems on this stuff, so I know you'll be looking forward to that. I'll see you guys tomorrow.